In this video, we are going to learn use of subqueries along with aggregate functions. We have learned that subquery is a query within another query. Also, we have learned in past modules how to use aggregate functions like min, max, average, etc. What if we add these two options? Then we will have subqueries with aggregate clause. Subqueries with aggregate clause includes an aggregate function which will further be used in the outer query. There's no such syntax for it since you can use it in from clause or where clause depending on your requirement. Let's see few examples for the same. Let's use a favorite table on Metabase, that is employees detail. I've placed a subset of the rows on the screen. This will help you in order to visualize the output with some smaller amount of observations, right? Like employee ID, first name, last name. Only this 6 columns are mentioned, although you know that there are more columns in employee detail. Whereas we know that there are thousands of employees present in employee detail table. You can see on screen that we have 5 rows only captured over here just to familiarize you with the data or to refresh your memory. Okay, so we will actually work on the larger data or the complete table when we go to Metabase. Meanwhile, what's the problem? So the problem that we are trying to solve over here is get all the data for the employee who has the highest salary. Strictly based on the table on the screen, can you figure out the output? As you probably would have figured out, we need to return this row of the data. This is because this is the employee data for which is associated with the employee who has the highest salary in all these rows shown, right? So great, we saw how to get the output on a smaller amount of rows. But this output may differ on a real case, which has 1000 observations in employee detail table. Now, let's go to Metabase and see the actual employee detail data. We will also write the code and see what the larger table output looks like. Let's have a look at employee details table. So as we discussed, there are 1000 employees, right? There are 1000 employees over here and we have their different details, employee ID, first name, last name, email, hire date, department, gender, salary, region ID. A subset of this we have just seen few minutes back, right? So let's proceed with our problem. What we are trying to do is we are trying to get all the data for the employee who has the highest salary. This is what we are trying to get, right? So let's do select star, which will select all the columns from which table? From employees detail table, correct? What is the condition where salary of the employee, whichever employee meets this condition? What is the condition where salary is equal to the maximum salary? So how we will get the maximum salary of this table? We have to run a query. What is that query? Select max of what? Salary, because we need to know what is the maximum salary. From which table? From employees detail table. So we will get the maximum salary. This inner query will give us the maximum salary, and whichever employee has this maximum salary, that will come as an output. Let's run this and we got the output. So employee ID 348, Jacqueline Finlater is the person who has the highest salary, that is 1,66,976. So great, we have been able to see how we can use max, that is an aggregate function, in subquery. So now let's solve another problem. Once again, we will refer to the smaller subset of the data shown. And the problem that we will solve is to get the proportion of count of employees working in each region. So let's figure this out together. How many employees are there in region? Let's get this info first in the table on the right. I've copied over each of the distinct region IDs. Can you tell me the count for each region ID in the blank column? All right, this was pretty simple, right? We have 2 employees in region ID 3, right? We have 1 employee in region ID 4. We have 1 employee in region ID 5. And we have 1 employee in region ID 7. Great. But according to our question, we don't need just the count. We need the proportion of the employee count in each region. That means we need to divide these employee counts by the total number of employees, which is 5. Hence, we calculate the proportion as shown. Total number of employees are 5. In region ID 3, we have 2 employees. So 2 divided by 5, we have 0.4 employees, or 0.4 is the proportion of employees that you have in region ID 3. Similarly for region ID 4, 5 and 7. Now that you got the concept, let's try this with a much larger employees detail table on Metabase. We will see the code and output over there. Okay. So what we want is, we want to get the proportion as count of employee working in each region, right? So how we will do this thing? First of all, I want all the details. So select star. From which table we want? We know that employees detail table, correct? Now, do we want all the details? No. What we have seen in the output, we want region ID and the employee proportion. So let's see that region ID is very straightforward. But do we have a column which gives us the employee proportion? No. What we need to do is that first we need to get the count, right? Of which column? Of employee ID. Right? This is what we want to get. Then what we did is, we divided it by the total number of employees present in employee details table. So we will divide it with the total number of employees. We have to get what is the total number of employees. How we will get? Using the subquery. So select count of employee ID from which table? From employees detail table, and we want to name this column as let's say, as we saw, EMP prop, that is proportion by region, right? So this are the 2 columns that we need, but here's a catch. We don't want just like that. We want based on region. So why, when we have to do region wise, what we should do? We should do a group by, right? So group by on region ID. And let's do one more thing over here. Let's sort the region ID also in our output. So we will do a order by on region ID as well. Let's execute this. We got the output. If you see, we have different region IDs in sorted order, and we are getting the employee proportion, which means whatever is the count of employee ID in region 1, in region ID 1, we are dividing it by the total count of employees present in the employee detail table, and this is the output that we are getting, right? Awesome. So, great achievement. So now let's see one more problem. Once again, this is a smaller subset of data shown, and we will try to get the proportion of total salary for each department. Looks similar, right? It sounds very similar to the previous question. But the only change that we are having is, we want the total salary, correct? So suppose we arrange all our departments shown alphabetically. we get these corresponding salaries, we have to consider these as the total salaries for those given departments, even though they are repeating only once in a subset table. But there can definitely be more employees in each department in the real case, which has much larger number of rows, right? Anyways, once again, we are not done yet. We have to solve to get the proportion of total salary, correct? This means we divide each of the values of salary by the sum of these 5 total salaries, which if we calculate is 4,81,910. So if we divide it, we will get this proportion. Like for clothing, we will get 0.2, for computers 0.11 and so on. So now that you got the concept, let's try this with a larger employee detail table on Metabase. As usual, we will see the code and output. So what we are trying to achieve is get the proportion of total salary for each department, right? So let's see how to do this thing. Select what we want in our output. We want department, right? And we want proportion. But we won't get the proportion directly. For what we want the proportion, first we will each department wise we want to get the total salary, that is sum salary. Then we have to divide it by the total salary of the entire table, that is select sum salary from employees detail, correct? And we need to name the column as salary prop by department. Okay, done. From which table we will pick this up? From employees detail. This also done. Now I want department wise. So very clear, we have to do a grouping, that is group by department, right? And further we have to do a order by, so that they are in alphabetical order as we have seen just few minutes back. So order by department. Let's execute this query. And we got the output. If you see, the proportions have changed what we have originally seen on the screen because this is a larger table. For automotive, the proportion of salary is 0.039. For music, the proportion of salary is 0.029. Similarly, for toys, the proportion of salary is 0.053. So we got the output as expected. Awesome. So to summarize, in this lesson, we learned about subqueries with aggregate clause, which includes an aggregate function, which will be further used in the outer query. We have seen some examples with count, max and sum, but we can certainly use various more kinds of aggregate functions depending on our use case. In the next lesson, we will learn about multiple subqueries in where clause.